Today we continue our 3D printer fix-up with part 3. Hello everyone, Chris here. I hope you're all well. And yes, we're continuing on our mission to get my original 3D printer kit, the Geeetech Pro B, printing as good as a lot of the budget printers we have nowadays here in 2020. Now we did switch out some parts in the last video. We upgraded some of the motors, but now we need to update the firmware to match some of the changes we've already made, and just to get it updated in general. I believe the version that's running on this one right now is 1.1.1 of Marlin. So we've come a long way, and that's going to help us out on this build greatly. Plus I also have some safety concerns around the mains voltage and the power supply altogether. So I want to address that, get some things rewired, and just continue to make this whole machine even better. So let's not waste any time, let's jump right into VS Code and get to creating a config we can use on this machine. As with any Marlin build, I highly recommend you go out to marlinfw.org and you grab the latest version, because you're probably going to have the easiest time setting that up with the least amount of bugs. So we'll go to download. We are currently on 2.0.7.2. I'll just hit download. And while that's downloading, we're going to head to the Marlin GitHub. And on the main page, we'll click in config. And then we're going to go to this link and it's going to download all the example configurations. With a printer like the Geeetech Pro B, it's been around a while. I have no doubt that there's already a solid config out here for it. So we don't want to reinvent the wheel anywhere we can save some time. So we're just going to use this config and then alter it as we see fit. So we'll go ahead and download this zip. Now we'll head to downloads. We can go ahead and extract all on our configurations. And we will also extract all on our Marlin folder. And I just like to complete it with the version that we're on, 7.2. And we'll extract. So you've seen me do this a lot before, but that Marlin folder that's inside our Marlin folder, that's just what it does when it extracts it. We're going to rename that to something so we know what it is. So again, I just like to use the version. So 2.0.7.2. And then the printer name. We'll just call it Pro B. Now we'll head back to downloads and check out that configuration file we extracted. And we'll head into configs. And this should all be listed in examples by vendor. So we'll head to Geeetech. And we have Prusa i3 Pro B right down here. And it looks like they have a config for no probe at all and for BLtouch. So we don't even have to do that part. We're going to take the BLtouch version and we'll just copy this configuration.h file, right click, copy, head back to downloads, our extracted 2.0.7.2 folder, go into Pro B, then into Marlin, and we'll paste our configuration right here, and we'll tell it to replace the file. Now we already have our configuration file that will fit our Geeetech that somebody else has already helped us out with. So now we'll go to VS Code. And we have an empty workspace, so we'll just hit Add Folder. Make sure you're on File Explorer up here. If you need to know how to set up VS Code, there is a link in the description. We'll head to Downloads, into our 2.7.2 folder, and we're going to add our Pro B folder. Remember, add the folder that contains the Marlin folder. You know you've added the right one because it'll start building and you'll have a PIO folder up here. That means Platform IO is laying all the groundwork. So let's expand Marlin and we'll open up configuration.h. Now again, most of this we shouldn't have to tweak. It should already be done for us. They've even added the BLtouch. But let's just scan through and make sure everything's set correctly. So serial port, we do want it to set to 0 because this is an 8-bit board. That's the most common setting for those. 250,000 baud rate is good. We do have the Revision A Plus board. There is a Revision A and a Plus. We have the newer one. The biggest add to this board is a port for your servo for your BLtouch. Just be aware that there are two different boards. The easy way to tell is to find those pins, or the older board has the green power and extruder connectors. The newer board has the blue ones. I'm okay with custom name i3 Pro B. That's okay. Thermistors are both set to 1. That is correct for these printers. That issues the regular 100K. Max temp on these, I'm going to set it pretty low because it does have a PTFE lined hot end. We're going to go 255 for max, and on the bed, I'll never get over 100, I would imagine, but let's set it to 110. The power supply on this isn't very big. I don't want it to have to draw any more than it has to. PID settings, it's probably just fine, but we're going to run an auto tune just in case. We're going to leave all the drivers stock for now. We do just have the old school A4988s. That's what it defaults to, even if you don't uncomment those, by the way. Now they've done some tricky stuff with the motion settings down here. They have an if statement. I guess there is a version that has 4-start lead screws because that's the setting you would want to set. They've also reduced these counts to 7874. I don't know what calibration they use. Default they would be 80. We'll take their lead on this one. I think the extruder E-steps is probably a little high as well, but we'll do a calibration. We'll check the print with our calipers just to see if it makes any difference. The biggest change was that 400 for these 4-start lead screws. So we're good there. Max feed rates for this machine, I think that's probably a little high, but most of the time this is all set in the slicer anyway. Same way with acceleration, that's probably a little too high for this machine. We'll tune all that in. We are going to go with junction deviation. They have set it to 0.4, default is 0.3, so not too far off. Now their Z-probe setting is a little bit interesting because I have always used my Z-min pins. That's how I have it hooked up on my board right now. They are using a pin 32. Now I don't know if they wanted to use their Z end stop switch as well. We might play around with that configuration later, but I intend to use Z-safe homing in the middle with the probe for now. So I'm going to go with my gut and comment this one out. And I'm going to uncomment Z-min probe uses Z-min end stop pin. And you can confirm that in the pins file if you'd like. Come over here to source, pins. This is a 2560, so I'm guessing it's under Mega. And here's the board we're using, GT2516 Rev A+. And remember, these are sometimes just breadcrumb trails, so they have included the pins for the Rev A. So we'll go into Rev A. Your Z-min pin, which is the one we're using, is set to 30. So that should be okay. But then if you saw in that Rev A Plus version, they have a servo pin for 32. When you enable BLtouch, it goes to default servo 0. So telling it pin 32 probably makes it not work. So remember, back in configuration.h, right here, if you tell it a probe pin, that's the trigger pin, not the servo pin. So we're going to go with Z-min pin. I think that'll work just fine. And then down here, you should have BLtouch uncommented. That will know to use servo 0, which is pin 32. Moving on, we will need to update our probe offsets because our mount is just a little bit different. You can see on our BLtouch mount, we're actually just a little bit right of the nozzle and a whole lot in front of the nozzle. So we'll just measure that with a ruler and then we can punch in our values. So we're about 44 millimeters in front and about 2 millimeters to the right. So they got it really close. If you're in the front on the Y, that's going to be a negative value, so they do have 44 in there. And if you're to the right, that's positive. They have 4. So I'm going to take mine down to 3. I think it's a little less than that, but that would have been close enough. No big deal. And I'm going to set my offset for now for the Z to 0 so I can dial it in. I don't have to worry about it crashing. So we should be good there. They've set multiple probes to 3. That's pretty good if you want it to be super accurate, if you want it to go faster. I'm just going to set mine to 2 for now. Bed size, this is a 200-200, and we do have some minimum values. And those are when your nozzle is outside of the bed before you start printing. And it's kind of hard to judge from the camera view, but we are quite a bit left of the bed and just a little bit in front. So those values are probably good. If we're not printing on the center of the bed, we're not making it there, those are the values we need to adjust. And then 200 for the Z, that's probably a good mark. Bed leveling, we will leave it bilinear. They have set the grid to 4. For this video, I'm just going to go 3, just so it's a little faster while we're working with it. You might want to consider higher values if your bed isn't all that level. Glass, it shouldn't be that big of a deal. And then Z-safe home. We are going to home in the center of the bed. EEPROM settings, we want to make sure those are enabled because we are going to save some settings in EEPROM. Our heat settings, I like to start with PLA at around 215 when I preheat, fan to off, and ABS 240 is max, we'll set to 100, I don't want the bed to go that high, and the fan will be off. Nozzle park, I'm going to go ahead and enable this because I want to use M600, that's filament change, if I need to use it, it'll be there. I like it to park in the front right corner, so I like to do X max minus 10, so 10 less than maximum, and then Y minimum plus 10. So it moves the bed out just a bit. And then in Z20, that means just wherever it is, it will lift it 20 from there. And then getting towards the end, SD support, we'll make sure that's on. We can adjust the way the menus move if we need to. We have to test that out. You can turn the speaker on if you'd like. And I just want to make sure it says RipWrap Discount Smart Controller, because that's the 2004 display that we are using. Everything else in here should be good. If you want to check on servo settings, they are down here all the way at the bottom. They are commented out. The BLtouch settings should take care of all that for us. So let's open up configuration_adv.h. They didn't give us one of these files for this printer, but there's not a lot that I want to edit as of right now. The first thing I want to do is kick on baby stepping. This will allow us to adjust the Z offset on the fly in case we don't get it quite right. And with that, I like to enable double click for baby stepping. That way you can click the wheel twice to get the menu. That's while printing. And then down here below, we're going to enable baby stepping Z probe offset because we do have a Z probe. That way it's actually adjusting the offset and we can save it in the EEPROM later so we know what the offset is. It's not just adjusting a few steps here and there. We're actually recording that setting and we can change it with M851Z. You'll see that more when we get it leveled. The next thing we come to, it's right under baby stepping, is linear advance. I am going to go ahead and enable it. We might not get it set up in this video, but it is going to help print quality greatly. And I'm going to leave the K value at 0 by default. We will set the K value in our slicer when we get around to it. But we'll enable it for now. More to come on this. And then the last thing we need is advanced pause feature. It's also required if you want to use a filament runout sensor, which we're not going to hook up right now, but I do intend to do that in the future. We can leave all these default. We will have to adjust them. This is direct drive extruder. You can adjust how far it kicks it out, things like that right here. And I also want to enable this line so that we can use M701 and 702 from our screen if we want to. That just gives us an unload and a load button. Those can be handy at times. And since we don't have any smart drivers or anything like that at the moment, we should be done. We're ready to compile. So I'm going to go to Platform IO. And we are going to use the 2560 environment right here. And we're going to hit build. And our build was successful, and we have plenty of memory left to add other features as we go. So now the easiest way to do this, especially on an 8-bit board, is to just cable up USB, turn the printer on, and hit upload over here. Most of the time your computer is going to know that it's a printer and it can upload to it. Now it's always been one of my least favorite things about this design is you have to go through all these wires to get to your USB port. It's down underneath. But I think the changes that we're going to make here soon should help with that. We are powered on, we are cabled USB, we are going to hit upload. It is flashing. The flash is complete. So now let's just take it for a test drive real quick, make sure everything is working as we expect it to, now that we have our new firmware on. You'll notice we came up with an EEPROM error. That just means we have a newer version now, and the stuff that's in EEPROM is old. We're going to go ahead and allow it to reset. That's always a good idea to do that anyway. Everything else on the screen looks just fine. And let's just run some basic commands. Let's make sure we can home X. Good there. Home Y. Good there. Let's go ahead and home all. We moved to the center of the bed for Z-safe homing. That's a good sign. And we did finally Z-home, but it is super slow. So we definitely want to put that on the list of things that we need to update. But the sensor is pretty close to the center of the bed, so a lot of those values should be correct. So that's a good sign. Let's just make sure we can heat up for both real quick. Both are reading the right temperature and getting warmer. I'm going to go ahead and shut off the bed. Now I just want the hot end to get up to temperature so I can make sure the extruder is turning the right way, and I'll be satisfied with the initial upload. And judging by my visualizer right there, we should be all set, turning in the right direction. So now I think we're good to move on. So now we're going to move from the firmware configuration for a bit and focus on some safety issues and some rewiring that needs to be done on this printer. Then we'll come back and tweak the firmware and make sure that it's going to print successfully. So this has always been a concern of mine, and I've been meaning to change it up forever. But if you'll notice, right here is where you plug the printer in, and there's the switch where you turn the power on. And please, don't do any of this while the printer's plugged in. But just that switch right there, right above it, that's mains voltage. Now, it does have this transparent yellow cover on it, but that's not good enough. If you're reaching behind this printer looking for that switch, it wouldn't be a very far stretch to get a hold of one of those lines, and that's not going to make you real happy. Also, the power wire they use for the DC has always been just a little bit too long, and you'll see more of that when we get over to the main board side. We'll have a little bit longer discussion about that one. But fortunately, again, this printer's been around a while, so there's a lot of great parts out there for it, including this cover. It's over on Thingiverse by J. Dobre. It puts a cover over the bottom of the power supply, moves the receptacle and the switch out, you don't even have to use a new one, and makes things a whole lot safer. So that's what we're going to do now. So I'm just going to remove it. It has a couple of screws here in the back. Then we'll just pull off all our wires so we can rewire it. And I probably said this before, but this is 12 volt, 15 amp. This really isn't enough for a 3D printer. At least shoot for 20. It does work, and it's been working for years, so I'm going to go with it for now. But if you're building one, don't get one this small. Give yourself some room. So now the DC wires on this printer. Now, these are two sets of 18 gauge. The board on this acts just like a ramps does. You have a 5 amp and an 11 amp side. They are both fused and they're separate. So you're supplying one of each. One is pretty much everything on the board at 5 amp, the rest is for the bed. Now you can look around all over the internet at different ratings and charts, but they're going to list occasionally 18 gauge wire at 20 amp. Now that's max, right? That's as much as you can load it before it starts to melt the insulation and burn up. I think that's a little high for 18. We do have them split up into two different sets here. It's probably going to work, but you definitely want to make these as short as you can. Don't hamstring yourself. I mean, an inch here or there doesn't really matter. But you want them short, and you want the connections to be nice and solid. And we'll talk just a little bit more about that when we get to the other side on the board. And as far as the AC wires go, they're fine, but let me just pull both of these out so I can show you them a little bit better. They just have everything rigged up on this switch. The switch is dividing both the neutral and the line, but you really don't need all of this to fit it inside that housing. We just need to get over to this receptacle. So I'm going to cut mine down a bit and re-crimp these ends. So the receptacle and the switch slide in nicely into the case just like this. You can use the same screws that you had on your kit to fasten that down. And I'm going to go ahead and reuse the incoming side of the wire. Anytime you reuse a connector, make sure they're nice and solid. But this bottom one, that's ground. The blue wire will be neutral. That's this one all over here on this side. I'll show you here in a second. Right there. And then the brown one is your line that goes on the other side. Just like that. And if they've changed these up over the years, you might see a white and black wire. That's how it is here in the States. Black will be your line, substitute it for brown. White will be neutral, substitute it for blue. This shouldn't matter so much which one goes where, just as long as you keep them separate. But I'm going to put the line on the bottom, down here on these two, and the neutral on the top. So there's the line and the neutral coming into your switch. And then hook up the ones that go to your PSU, neutral, and then line. And just a test fit of our power supply, there should be more than enough clearance in there, but I'm still going to go ahead and shorten these other ones up, these guys here. Those are just way too long. We've got our wires shortened up and our connectors on. Now we go ahead and put them back on the power supply. Most of these are going to have badging on them to tell you how to hook them up, but most commonly you have line on the outside, neutral in the middle, and then ground on the inside. And for the DC wires, I am going to go ahead and use the stock ones, but we're going to shorten them up on the other side, the board side, here in a moment. So I'll go ahead and hook those up too. For those, you should have at least 2 commons side by side, and then 2 voltage ones side by side. Most of the time you'll see 3, but not on these smaller ones. So just make sure both reds are on one side, both black are on the other. Again, they'll be badging up here to tell you which one's which. Now this cover, to mount it on the power supply, it has a spot right here where you can slide a nut into the plastic part. I'm going to use a square nut because I think it'll fit a little bit better, but you might be able to get away with a hex nut in there as well. And then I'll just use an M3x10 screw to snug it together. And the cover's on. Now the cover just has that one screw to keep it all together, but after you get it back on the printer, there are mount holes down here for these. That'll make the whole thing really solid. You shouldn't have to worry about it. After you get the cover on, make sure all those connections that we just did are tight once again, and there should be no issues going forward. It's going to be a lot safer. Now for the power supply, I'm just going to use the stock locations to try to locate it somewhat correctly. The stock holes aren't really straight anyway, but then I'm just going to mark and drill a couple of holes for the ones for the case. There's probably a better way to line that up, but it shouldn't be too difficult. And now it's installed. So overall, I'm pretty happy with it. I was able to use the stock hole that was with the old plug, the one on the right side. For this one, I did drill a new one in the acrylic for this guy down here. Again, M3x16mm screws, nylock nuts, came out pretty well. The power supply, I was able to use the 2 stock holes and the stock screws. So this will be a huge safety improvement going forward. Pretty excited about that. I don't like getting shocked. Now we're going to move to the board side. We're going to deal with the power wires first, and then we're going to use a case. I'll get to that in a minute. But these power wires, at some point, I had spliced on this Molex connector because that's the connector that was on the board. Those are not the best connectors, and there's way too much wire here. So what we're going to do is we're going to replace the connector, put a new Molex connector on, make this a lot shorter, and the shorter it is, the better off you are. Remember, this is 18 gauge wire. 18 gauge is the biggest that will fit in this type of connector that's on that board. Again, we're kind of at the high end for those connectors. You need to make sure all of your crimps are good and everything is seated properly. So I'm just going to cut this one off, and then we're going to crimp on a brand new connector with the proper pins to mate up with the board. These are a specific size. I'll leave a note in the description for which ones these are. Make sure when you splice your wire, you've got enough to get down inside this pin after these 2 tabs, but you also have some insulation to grip. I just like to set the pins in the jaws of my crimpers just like this, and then slide the wire in. And that is what a pretty solid crimp-on is going to look like. You need about 5-6 millimeters of wire spliced back, but you want some of that insulation as well. It takes a while to get the feel for this. You only have to do 4. I really don't like doing it either, but it is a much cleaner install. My crimps are on, and on the Geeetech board on these plugs, the top row is positive, bottom row is negative. Doesn't matter which wire goes where, just make sure you have the red on top, black on bottom. Assuming the top has the clip on it. And our plug is on, good as new, and it's a little bit shorter, but should be a whole lot safer than the setup we had before. Now let's move to the board cover that I found. This is a case I found over on Thingiverse by Lukey80. Lucas has done a great job on this. It is somewhat adjustable just in case your board isn't quite the same size. There's a couple of slots down in here. And we should be able to do wire management out the bottom and the top and put most of it in this channel here. This is really going to clean up the look of the printer, but we pretty much have to redo everything to get it installed. It also has this lid. The lid, you can use 2 40mm fans to cool down your board and drivers if you want to. And I believe you can use 4mm screws to connect it. So I'm more than likely going to move that one 40mm fan that's on the acrylic to the top of this. So now I'm just going to pull all the cables off the board. It might be useful if you took a couple of pictures before you do this. I'm pretty confident that I remember how it's wired up because I've worked on it so much. But we'll get that done. And once the wires are off, these just set on those plastic feet like you see in a PC case. The new cover will actually screw on to the acrylic here, so I'm just going to remove those off those tabs. And the board is loose. Now we can go ahead and try to test fit our cover. And it looks like this cover was actually designed around the original GT2560 board. And you can see one of those right here. This is the first board I had on this printer. It's actually just a little bit more narrow than the Plus revision board. I think we can make this case work, but if you're going to print one of these, maybe scale it up just a bit. It's about 2 millimeters wider. I was able to get it to fit with a little bit of rework, but I will leave links in the description of cases that'll work for either board, the old one or the newer one. And one thing I've never really liked about this board is where the USB is. It's kind of handy to have the power and the hot end power for the beds, things like that down here at the bottom, but not the USB. The case does line up with that so you can get a cable in there, but I still really don't like that design. We can live with it, just something I wanted to point out. And after you get your board in there, just make sure your case still fits. Should be no problem. Now this whole thing, we're just going to put screws in from this side and use nylock nuts on the back, screw the whole thing down to the acrylic. First, I am going to go ahead and remove this fan. That's the one I'm going to try to reuse on the cover. For whatever reason, I used some really long screws on that. But you could probably reuse those to put your cover on your acrylic. And with that fan off, to give us some clearance, I'm just going to use 4 M3 by 20 millimeter screws and those nylock nuts I had on the fan to attach that cover. It just goes through the 4 screw holes that are in the corners of the board. Our board and cover are on, and it's looking better already. Now we can start routing some of our wires. Our power wires came from the bottom. This hole right here is just barely big enough for that connector to fit through, but it does fit. And then you can run it up, and there's actually just a little niche cut out right here, so they fit right into that socket. So that went well. And then over here on this hole, we'll bring our bed wires in from the side. Now, as I rerun a lot of these wires, I'm going to make some changes. I'm going to make some of these shorter. I want my bed wires as short as I can get away with. A little bit of slack doesn't hurt anything, but the shorter they are, maybe the little more efficient that bed's going to be. We also need to build in some strain relief on this bed. Because these move a lot and you don't want the wires moving with them, we want to be able to tie those down to something. We'll tackle that in the next video, but I'm going to shorten these up and then I'm going to use this sleeving rather than spiral wrap. This is 1/4 inch. I'll use that for the bed wires, and then I'll use 1/2 inch to replace the spiral wrap on the extruder wires. I'm also going to include my Y end stop wires in there as well. Probably just zip tie it down here so it moves from this location and doesn't pull on those. I'm also going to use ferrule connectors on the end of the bed wires, and I'm going to replace the JST connectors as I shorten up those wires. And on both the bed and the hot end looms, I'm going to run a piece of 3 millimeter nylon filament so that it is a little bit more rigid as it's moving. It just gives it a little more natural arc so it doesn't lay down on the frame or get hooked on something. And here's a better look at the bed wires after I cleaned them up. Also, for some strain relief around the back, I just drilled a hole in the acrylic and zip tied it down right here. That gives it enough room to move, but also gets the relief off the wires a bit. We also need some on the bed side, but again, we will address that later. Now we need to work on the extruder wire management, and I've never really liked this design. If you go all the way to the top of the Z, the motor's actually in front of the acrylic, so you can't run the wires in between there. They'd get pinched. And there's not enough length to run them over, and that doesn't make a lot of sense. So your best bet is actually to run them below the belt and above this smooth rod. Now it might rub a little bit, but we're going to have a sleeve around it, so it shouldn't matter too much. It should work out okay. I will probably have to make some of these shorter, maybe some of them longer. That's not that big of a deal, but I will have to redo some of the connectors, so be aware of that if you're going to do something like this. I'm also going to use some nylon for this one to give it some support. And there's really no strain relief here. So what I've done is I've removed the bottom 2 screws on this motor, and I've created this part that will fit in those holes. That way I can zip tie that loom once I get it in that sleeve to the back of this. That'll also keep it out of the way for when you're going all the way to this side of the printer. And I'm replacing these screws with some M3 by 40 screws. That'll be long enough to get through this strain relief and into the other side of the motor. So I'm going to work on that, but also I'm going to remove this extruder for a second because I want to show you what I did about the part fan mount. Now in the last video we installed this part fan duct, and it was designed just to have the fan set on here. It was just a press fit, but that really doesn't secure the fan very well. So I came up with a mount that should help out a lot. And that's this part right here. It will hook on to the screw holes on that 50-15 fan, and then this one can mount on one of the existing screws, but that screw has to be just a little bit longer. So from the front side, I swapped this screw out. It holds the belt mount on, the part with the teeth. I swap this one with an M3 by 25mm screw, and then I use the extra thread on the back to hold my mount on. So with that longer screw, I can just slip the mount on. I can use an M3 nut on the end of that screw to hold it in place. And then you can slide your fan back on, and then use some M3 by 30mm screws to secure the fan onto the mount with some nylock nuts. And that should make that whole assembly much more stable. Now we can go ahead and put our extruder back on and continue to work on our wire management. So we're doing pretty good with the extruder carriage, the hot end, and the fans. I also rerouted the X motor and the end stop. I've made a lot of these shorter and replaced a lot of the plugs. I just want to get it as neat as possible. I know it might not seem like much watching the video, but this actually takes a ton of time to redo. But I want to do it just this last time and be done with it. So we still got the Z motors and the Y motors to reroute. I'll have to shorten these up. This case probably needs one more entrance added. I can probably get one of the motors in here where the power comes in, but this port over here is for the LCD cables. I'll probably route my Z motors through there. But I have more than enough length on all those wires to get them where they need to go. So we're in pretty good shape here. I've got all the wires put back on. Everything fits nicely in the box. It does bulge a little bit, but the cover will take care of that. Now the cover does have two fan holes on it that we can use 40mm fans. And we do have an extra fan now because it had one on the acrylic right here. So I'm just going to put that fan on the outside here with some M3 by 16mm screws. And then there's extra always on fan pins up here on this board. Those are constant 12 volt. It might be a little noisy, but that's exactly how it was hooked up before. So that's just what I'm going to do. I just pull the fan wires through so they'll go through the case. The motor wires and things we ran down here, the Y motor, and then I got the two Z's through here. That is a little tight in here. You might have a hard time getting all that back out. Hopefully we don't have to worry about that for a while, but you'd probably have to pull that power plug first to get the rest to come back through. Again, I think it could use one more opening, but I'm pretty satisfied with it overall. Our fan's on, and then we can just put the cover on. These are M4 threads. I'm going to use some M4 by 16. With all that set, there is one more thing I'd like to tackle, and that is this strip light that I have on the gantry of this printer. This is really handy, but I haven't had it hooked up in a long while. Now I have it kind of running past down here. I should probably cut that a bit. I was going to try to power it with one of the pins on the board, but I think the draw on these is actually just a little bit too high for a regular set of pins. So this is a 12 volt strip. I'm just going to solder some wires on the end of this, poke a hole in the side of my power cover over here, and hook them directly to the power supply. That's probably the safest way to do it. Now, they will be on when the printer's on all the time, but we can live with that for now. We got it plugged in, we'll hit the switch. Lights came on, BLtouch cycled, all the fans are running, Marlin is booting, everything's looking good. Now again, we have a lot more stuff to do inside the firmware to get things tweaked, and I want to rework this bed a bit, but I think I'm going to save all that for the next video. We've done a lot here. It didn't improve the print quality, but it's going to make it a lot more consistent going forward, and it's just a lot cleaner look. The biggest thing today was that Marlin upgrade. So I think that's where we're going to leave the 3D printer fix-up for today. And I don't want you to feel like I left you hanging on this one, because we didn't make a lot of modifications that are going to improve print quality. But we did improve aesthetics and safety greatly, and that Marlin firmware update is going to be crucial as we move forward, because there's going to be a lot of features that we want to use. In the next one, we'll tackle some things that I want to improve with the bed, as well as wire restraint, and just general updates. Finally, maybe we'll get that LCD hooked onto the printer. So that's it for today. I hope you liked this one, and I'll see you really soon on the next one.